You've probably heard that Mount Everest is the tallest mountain on Earth, the ultimate symbol of height, of reaching up, of standing as close to the heavens as a human can. But what if I told you Everest is not the closest point on Earth to outer space? That where Earth truly meets space is somewhere else, somewhere far more surprising. Today, we're going to explore that boundary, where Earth ends and space begins. Let's start with Mount Everest, towering at roughly 8,848 meters, or 29,029 feet above sea level. It's iconic, a magnet for climbers, adventurers, dreamers. Yet, when we talk about getting close to space, Everest's height barely scratches the surface. Why? Because height doesn't just mean elevation above sea level. To understand where space begins, we need to think differently, not in terms of how tall a mountain is, but how far you are from the center of the Earth, and more importantly, what altitude you need to cross into the realm of space. Here's where things get interesting. Our planet isn't a perfect sphere. Instead, it's an oblate spheroid, meaning it's slightly flattened at the poles and bulges at the equator. Because of this bulge, places along the equator are actually farther from Earth's center than places near the poles. That subtle fact has a mind-blowing implication. Somewhere on Earth that isn't Everest is actually the closest point on Earth to outer space. And guess where that is? Ecuador. In Ecuador rises Mount Chimborazo, a volcano that reaches about 6,263 meters or 20,549 feet above sea level. That's much lower than Everest when measured from sea level, yet because of Earth's equatorial bulge, its summit is further from the planet's center than Everest's peak. In fact, Chimborazo's summit is roughly 2,150 meters, about 7,050 feet, farther out into space than Everest's peak, making it, in a very real sense, the closest point on Earth to outer space. That's not just trivia. It changes how we think about height in a cosmic context. It's not about how high you are above sea level. It's about how far you are from the core of the planet. Okay, so Chimborazo is the closest mountaintop to space, but that still doesn't mean it touches space. Because where is space exactly? When does Earth end and outer space begin? Good question. There's no magical wall or physical barrier. The atmosphere doesn't suddenly stop. It gradually thins out. But scientists and international bodies needed a way to define a boundary, to distinguish between aircraft altitude and spacecraft altitude. That's where something called the Kármán line comes in. The Kármán line is a widely used, though not universally accepted definition for the boundary between Earth's atmosphere and outer space. It sits at about 100 kilometers, or 62 miles, above mean sea level. Why 100 kilometers? Because that's really the point where aerodynamic flight stops making sense. At lower altitudes, airplanes rely on lift, pushing against the air. But as you go higher, the air becomes so thin that lift is no longer effective. Around the Kármán line, you'd need to go so fast just to fly that you're better off going orbital. You're not flying anymore, you're in space. The line bears the name of Theodor von Kármán, a Hungarian-American physicist who did the calculations to find the altitude at which aerodynamic forces give way to orbital forces. Of course, not everyone draws the line at 100 kilometers. Some groups, including NASA and the US Air Force, use a lower threshold, around 80 kilometers or 50 miles. Why the difference? Well, there's no clear-cut physical surface where space starts. The atmosphere fades slowly, and depending on which criterion you use, lift versus orbital mechanics, the boundary shifts. In fact, astrophysicist Jonathan McDowell argues that 80 kilometers might be a more physically accurate boundary than 100 kilometers. Between those numbers, it's kind of fuzzy. The atmosphere doesn't just end abruptly, it thins progressively. You might wonder, why do we even care where space begins? Isn't it just technical? But this boundary, the Kármán line, has real-world implications. Astronaut status, Some organizations award astronaut wings based on crossing that line. Legal territory. In airspace law and treaties, what's considered space affects sovereignty. National borders don't extend into outer space in the same way. Technology design. Aircraft, rockets, satellites. What kind of propulsion they use depends on whether they are flying in atmosphere or space. So it's not just academic. It's a conceptual border that affects engineering, law, and how we acknowledge human achievements. To really grasp what's going on, we need to understand Earth's atmospheric layers, how they thin out, and where space-like behavior begins. The atmosphere isn't one uniform thing. It's layered. Troposphere, starting from Earth's surface up to about 8 to 18 kilometers, depending on where you are. This is where weather happens. Stratosphere, above that, up to around 50 kilometers. Mesosphere, from there up to about 85 kilometers. Thermosphere, from there up to several hundred kilometers. Here the air gets very thin but still present. Exosphere, the outermost layer, where particles are so sparse that they can drift into space. Even above the Kármán line, traces of the atmosphere remain, so space is more of a gradient than a wall.
So, Chimborazo is the closest mountain summit to space, but that doesn't mean it's in space. It's still way below the Kármán line and far below 80 to 100 kilometers. We're talking kilometers, not just thousands of meters. The real crossing into space doesn't happen on a mountain. It happens at altitudes only reachable by rockets, balloons, or very high-altitude planes. For example, the International Space Station, ISS, orbits at around 400 kilometers above Earth, well above our space boundary. Explaining science. Some suborbital spacecraft and experimental vehicles reach altitudes just above the Kármán line. If Chimborazo is physically closer to space in terms of distance from Earth's center, why does Everest dominate popular imagination? Because humans measure height from sea level. That's what matters for climbers, for maps, for record books. Everest's iconic status is mostly about vertical elevation from sea level, not radial distance from the planet's core. Our mental image of highest is tied to how we climb mountains, not where space starts. When you stand on the summit of Chimborazo, what do you see? Clouds below, perhaps? The curvature of the Earth might be more noticeable than from many other places. But you still don't see space. The sky is still blue, the air still wraps around you. To truly see space, the blackness, the stars, the void, you'd have to go much, much higher. And that's what rockets do. They take us past the fuzzy boundary of our atmosphere, past the Kármán line, into outer space. There's something deeply poetic about this. We often think of reaching for the sky, of standing at the edge of the world. But in cosmic terms, that's not quite accurate. Our true frontier isn't a mountain peak. It's an invisible line, hundreds of times higher than the tallest mountain. That boundary is not fixed. It's debated, blurry, and defined differently by different experts. But in that fuzziness lies the wonder. Space isn't separate from us, but an extension of our world. It's not a sudden drop-off. It's a continuum. So, why does it matter that Chimborazo is closer to space than Everest? Because it challenges our assumptions. It teaches us height is relative. How we measure highest depends on the frame of reference. Definitions are human constructs. The Kármán line isn't a naturally etched cliff, it's a convention, a useful dividing line, but not absolute. Our perspective is limited. We tend to see the world in terms of mountains and sea level, but the universe sees something much bigger. And that's inspiring. It reminds us that the frontier isn't always what we think. Sometimes it's where science, law, and imagination come together to draw lines on the invisible. Think about this. Every rocket that launches into space is crossing not just altitude, but centuries of human curiosity. Every space tourist, every satellite, every astronaut is passing through that gray zone, that ambiguous boundary where air thins into vacuum. And down below, on Earth, there are mountains like Chimborazo, quietly defying our mental hierarchy of highest places. They remind us that our planet is not just a stage for climbing peaks. It's a complex shape, brimming with surprises. So, next time you hear someone talk about space, or how high Everest is, pause and remember, space doesn't begin at Everest. It begins far above, at an invisible line drawn by human minds at the meeting point of gravity, air, and our dreams. So you won't believe where Earth meets space because it's not at the top of the world's tallest mountain. It's at a far more subtle boundary, and the place closest to that boundary on solid ground is Mount Chimborazo in Ecuador, not Everest. That invisible boundary, the Kármán line, hovering somewhere around 80 to 100 kilometers above us, is where flight changes fundamentally, where lift gives way to orbit, where Earth's embrace fades into the dark expanse of space. It's a humbling reminder of how small we are, how fragile our atmosphere is, and how vast the cosmos remains. If you enjoyed this journey from mountain peaks to cosmic frontiers, make sure to like, subscribe, and hit the bell because we've got more mind-bending Space Meets Earth stories coming your way. And drop a comment below. What do you think of when you imagine the edge of space? Thanks for watching and keep looking up.